what I'm going to do today is I'm going to kind of give you the background math as to what is going on the unit circle, and that'll take us a little bit of time. And then the end, right before homework, is our first look at filling in a whole bunch of parts of the unit circle, okay? And then tomorrow when you come in, I'm going to give everybody one of these. I have enough. I can't give lots of copies. This is hole punched on pink paper, which you know what that means. We're going to fill this in again tomorrow, but we're going to do it much slower, neatly, because this will be your key. So tomorrow, you might want to have colors with you because it is nice to color code it a little bit. Not required, but it is a good way to look at it at a quick glance with all of the different colors. You have to bring your own if you want to do that. And then we're going to talk about even more patterns than what I tell you today. So here's the thing, though, my dears. You cannot sleep on this concept. You can't quit on it, okay? Some of you are really good at seeing patterns, and this is going to come really easy to you, and some of us, it's not. I will tell you it wasn't easy for me in the beginning until, like I told you guys, I learned it. I stopped trying to memorize. And that's really what today is about, is where does it all come from? So you kind of have that background, and then you can just start using it, okay? The key to Unit 3 is knowing your trig functions. The trig functions all come from your ordered pairs, and I'm going to show you that here in a second. And we have to know them without a unit circle. You will never, ever take a test or a quiz with a unit circle in front of you, so you have to know them. And I'm not trying to scare you, because if it were impossible, we wouldn't be doing it. I promise you, you can all learn it, but you can't just like quit on it, all right? So please just pay attention and listen. Like I said, you will have no homework tonight, okay? For me, anyway. All right, so what I want you guys to look at is this picture right here. This is a close-in view of the unit circle, an angle in quadrant 1 of the unit circle. So remember, the unit circle is just a circle on the coordinate plane. I drew it for you the other day. Here it is. There's the unit circle. Really scary. But this is zoomed way in. And we have the origin here. And we always make our angles coming out from the origin on the diagonal, which is called a hypotenuse. It's also a radius of a circle, right? That's a radius of 1. And then we make a right angle with the x-axis. And we talk about something called sine, cosine, and tomorrow we'll talk about tangent. So anything that has to do with tangent today, we're not. We're really just focusing on sine and cosine. So you might remember there's a little geometry review in this lesson. You guys might remember a saying called SOHCAHTOA. Does that ring a bell? Even if you don't remember it, somebody taught it to you once. This represents these relationships between the sides of a right triangle, which the unit circle is just a whole bunch of right triangles, a whole bunch of them, okay? And I'll show you that in a second. And the way we find sine is the opposite leg over the hypotenuse, opposite of theta. So if this is theta, and by the way, on the unit circle, there's triangles, right? There's 3 angles to every triangle by definition. And our theta that we always are talking about is at the angle that's made at the origin. So theta is always at the origin, okay? And so when we talk about sine, that's opposite over hypotenuse. That's where the OH, sine, is opposite over hypotenuse. The opposite side from theta would be over here. And then the hypotenuse is the radius, okay? The hypotenuse is always the longest side. It's the diagonal. And on the unit circle, all of our hypotenuses or radii are 1. By definition. Cosine is the adjacent leg over hypotenuse. Now, we are talking about the unit circle for the next week or so. Eventually, we get off actually sooner than that, we get off the unit circle. We just talk about any right triangle. So SOHCAHTOA is something that's useful in any right triangle, not just the ones on the unit circle. And this is going to become even more important then. So it's important to understand what these words mean. Opposite is the side that's opposite. It's like literally across the street. Like, hey, over there. Adjacent is a side that your angle touches. See how it's touching that? And then, of course, the hypotenuse is always easy to find, all right? So SOHCAHTOA is what we're going to be talking about more in a second. But for right now, let me look at the unit circle angle right here. So here's my theta, you can picture, even though it's not drawn, you could drop down to your x-axis and make a right angle. And then there's a point right here. So don't forget what you already know. How do you get a point? You go to the right or left, right? You do x first, then you go up or down to get your y. So to get to this point, we're doing our x and we're doing our y. And that will come from, and I'll show you more in a second, x is your cosine and y is your sine. This is the first thing you have to know, like your name. In algebra, all of our points are x's and y's, right? Points, x, y, x, y. None of you are confused by that. In trig, it's the same idea. It's left or right, up or down, but we call it cosine and sine. How do we not confuse these? Because think about it. None of you can, like, if I ask you for a point on the coordinate plane, if I said to you, what's this point right here? None of you are like, which one comes first, the x or the y? You just know it, right? Like, we all know how to name a point on the coordinate plane. And one of the things you might have learned way back in the day was that it's alphabetical order. X comes before Y in the alphabet. Same with domain and range. Input, output. It's all alphabetical order. Helps you remember. Same with cosine and sine. C comes before S. That's the order. It'll never be any different. Super important. Okay? Yes, on to the next page. So here's where I'm going to speed teach because I'm not really teaching it. Some years I just want to skip this because you don't really have to do anything with 30, 60, 90s or 45, 45, 90s. But the whole unit circle is made up of these special right triangles that have really special relationships that I'm going to go over quickly. Let me just show you, for example. Our very first angle on the unit circle right here is 30 degrees. This is a 30-degree angle right here. Okay? This is a 30, 60, 90. Then we have another angle that comes out here, and that is from here to here. That's a 45-degree angle. 30, then 45. Then we have another one that this whole thing is 60 degrees. And each of these triangles are right triangles, and they have either 30, 60, 90 or 45, 45, 90. And then we get up to the one at the top, which we talked about on Friday, which is a 90-degree angle. So the whole, and this is going to repeat the whole way around. That's where these ordered pairs are going to come from that are the key to everything. Cosine and sine of every angle. And so really, really quickly, you will never be tested on this in this class. You don't have to remember how to do 30, 60, 90s, but if I skip it, I feel like I'm not giving you enough information. There's a reason we have the ordered pairs that we have. So just really quick, the lengths of the triangle, of the legs of the triangle correspond to the angles 30, 60, 90. So in other words, this one's x, this one's x, square roots of 3, and that's 2x. So let me write it. So we have x is a 30-degree angle, x square roots of 3 is a 60-degree angle, and 2x is the 90-degree angle. Well, guess what? We know the 90-degree angle. The length of the side opposite our 90-degree angle is 1, because it's the hypotenuse, or the radius. And so x equals 1/2. Now, I'm going super fast because I don't want you guys to stress about this, but some of you will catch on to it and it'll make sense to you. Most of us, it really doesn't matter. But that's telling us that the side opposite the 30-degree angle is x, and we just found that this is 1/2. And I could do similar math for this one too, but those are the two sides of the 60-degree angle. So this is my cosine, this is my sine. Where did that come from? This is my x, this is my y. How do I get to that point? Left 1/2 up square roots of 3 over 2. So this ordered pair, and we'll show it again in a second. Really quick, let me just finish the other special right triangle. Again, we have an x of 45 degrees, an x of 45 degrees, and x square roots of 2 is 90 degrees. Our 90-degree angle, the side opposite, we know that one. So x square roots of 2 equals 1. And I'm not going to do the math, guys, but if I solved for x, I would divide both sides by the square root of 2, rationalize the denominator, and I would get x is the square root of 2 over 2. Well, x are both of these. They're the same measure, 45, 45, so their sides that are opposite the 45 degrees are also the same. So what's really nice is that our 45 degree angles have the same trig function. Cosine and sine are both square root of 2 over 2. Now, let's put this all together. So don't stress about that. I just wanted to just kind of know that these numbers come from the fact that these are special right triangles that have special relationships with each other's sides. And with the fact that we have a radius of 1, that's how we got those numbers algebraically, but you never have to come up with that. So, find the values for sine and cosine for the angle of 30 degrees. So we're saying that this theta is 30 degrees, okay? So what you're going to learn, and we're about to put it all together here in a few minutes, is that all of your 30-degree angles, which repeat 4 times on the unit circle, have a cosine of square root of 3 over 2 and a sine of 1/2. Okay, so that's what we're learning right now. Just stay with me. We're also going to see that our angles that are 45 degrees will always, like I said, this is an x and a y. We would call it sine and cosine, right? Cosine comes before sine. Here's the one issue, though, guys. Multiple choice or fill in the blank, a lot of times what's written first is the sign, and you have to fill in the blank, or it's multiple choice, you pick which one. Be careful, and I think it's because SOHCAHTOA sine comes before cosine when we say SOHCAHTOA, but don't forget, on the unit circle, C is your x, S is your y. So be careful about the order of these. I mean, on this angle it doesn't really matter because they're the same, but a lot of times you will see sine written first. When you have the choice, you can write it in any order you want. It doesn't matter. But here is our 60-degree angle. Right? You can picture that right angle dropping down. This is a 60, 30, 90, 60, 30, 60, 90, whatever. But bottom line is sine is the y value, cosine is the x value. So what you might have noticed right here, guys, is that your 30-degree angle and your 60-degree angle have the same values, just flipped. The whole unit circle, except for those 4 corners that we talked about, the whole unit circle only uses 3 fractions. Square root of 3 over 2, 1/2 square root of 2 over 2. The whole unit circle, the whole way around, in each of these quadrants, those are the only 3 things you have. You have to remember which one goes first, which one goes second. And we're going to talk about that. Don't worry. Stay with me. Right? And then there is remember how I was talking about the 4 corners on Friday? They actually have a real name, even though I like to still use 4 corners. They're called the quad. Think about 4, quadrantals. And we already talked about what their ordered pairs are, because it's just going out 1 unit. So for example, 90 degrees, oops, I have my notes all stapled in the wrong order. Where is 90 degrees? It's up here. So from 0, 0, we know that ordered pair is left or right 0, up 1. So sine of 90 degrees is 1. Cosine of 90 degrees is 0. Okay? So sine, cosine, and later tangent is all about the ordered pairs. And that's what we have to know. We have to know what is sine of 45 degrees, what's cosine of 180 degrees, and eventually you're going to know all those. Stay with me. One last connection I want you guys to make before we start looking at the unit circle as a whole is in example 10 and 11. Remember I told you guys on Friday that each of your angles on the unit circle can be measured, or any angle in the world, can be measured in degrees or radians, okay? And we're going to put all of these together. This is all those middle angles, the 30s, 45s, and 60s I was just teaching you about. But we also already went over the quadrantal ones. Is that word? Quadrantal, right? The degrees and the radians. So we're going to fill it all in again. Now, the connection between these, you've already learned. Remember on Friday we learned, I can convert degrees to radians or radians to degrees by a little formula. So if I wanted to go from 30 degrees to what its radians are, we learned how to do this on Friday. We simplified the fraction. and we got pi over 6. So that's where that's coming from. It's mathematical. It's an actual formula. We won't really use that formula going forward with the unit circle because we're going to memorize them. But if you choke and you're like, oh, I can't remember, you always do have a formula to go back on. Whether you know the degrees, you can go to radians, or the radians to degrees. Just flip that fraction, okay? All right, so what I want you to do is, I know I went really fast through all that. There's a reason for it. It's really going to start making sense when we do it on here together. So this can be your messy copy. You can make some mistakes and everything. Because remember, tomorrow we're going to make a beautiful pink one that will go in the front of your notebook for the rest of the year. Okay? So what I want you guys to notice, and I'm going to come back to what's going on with these radians in a minute. The radians are all filled in for us. Okay? And I'm going to come back to the radians. Let's kind of start with the degrees, though. So we always start here, right? That's our starting point. And as I just showed you, we have 30, 45, 60, 90. So this is 30 degrees. That's the smallest angle that's recognized on the unit circle. By the way, 0 through 30, there's still other angles in between here. But without muddling it up, you can picture this is just my 30-degree angle. Then this would be 60 degrees. Oh, no, sorry, 45. See, we'll do. Sorry, 45, and then this one is 60. It's mathematical, guys. It increases. 30 is smaller than 45, which is smaller than 60. And then we get up here to 90. Guys, this is quadrant 1. What I'm going to encourage you all to focus on is knowing quadrant 1. If you know quadrant 1, once I show you the relationship that quadrant 1 has with all the other quadrants, you're going to know the whole unit circle, okay? So let's stay in quadrant 1 for a minute. Is that the order I want to? I change the order. I go over this every period. Okay, yeah, let's just go ahead and finish quadrant 1. So in quadrant 1, let's do the ordered pairs, which is the key to everything. Because remember, your ordered pairs give you your cosine and your sine, right? That's what we get out of every ordered pair. And so we know this quadrantal. That's to the right 1, up 0, right? That's the unit circle, the first point. And what we just learned, because of special right triangles, is that this is square root of 3 over 2 and 1/2. This is square root of 2 over 2, square root of 2 over 2. And this is the flip 1/2 square root of 3 over 2. Now I'm going to come back and talk about this, just fill in this last one here. Okay? This is quadrant 1. What you have to memorize, look, this is what I know. I know with my ordered pairs that right after 0, the square root of 3 comes first. If I just know that, all the denominators are 2. Look, they all have the same denominators. And if I know that this is the square root of 3, well, this has to be the other one, which is 1/2. And then this is just flipped up here. So if I know this one, I know it can't be square root of 3 first here. It's got to be the other one. And then these are always in the middle. These 45-degree angles are always square root of 2 over 2, square root of 2 over 2. So if you just know this, you know the rest of quadrant 1. And what's going to happen is that is going to repeat over here. Let's now do degrees. So when I fill in the unit circle, and I can do it in like less than 2 minutes, and I should be able to, right? I do this all the time. You guys are going to have to do it in 5 minutes on Friday, which will be plenty of time. Okay, just stay with me on that, but don't get scared. Where I mess up personally is degrees. I'm not as solid with degrees, but here's what I want you to know. The degrees is just simple math. The whole way around the unit circle, I'm going 30 plus 15, literally adding 15, plus 15 plus 30. Then we're going to go 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. It's that same pattern the whole way around. So when I get stuck here, I'm like, oh my gosh, I forgot, because we don't use degrees as often. We have to know it, but we don't use it as often. I'm like, oh, that's right. I'm just going to add 30 to 90 degrees. That would be 120. And then I add 15 twice. So 120 plus 15 is 135. Add another 15. We'll go over here so there's room over there. That would be 150. And then you add 30. Well, we already know this one. That's 180, right? That's a line. So all I did was add 30, 15, 15, 30. Now, let's do the ordered pairs in quadrant 2. Watch this, guys. I use the word hug, okay? H-U-G. I say these two angles right here hug the y-axis. This is the y-axis, and hug it like on either side. They are always the same ordered pair. The ordered pair I have here is the same one I have here. We'll do the signs in a minute. Just stay with me. All of the middle ones that end in a 4, look, denominators of 4 or are in the middle of the quadrant, those are always square root of 2 over 2, square root of 2 over 2. And then look, we're down to the x. What did I do? Oh, sorry. Nope. Yep, we're down to the x-axis right here. The angles above, and in a minute you'll see below the x-axis, are exactly the same. So straight across, they're the same ordered pair. See it? But what's different about these ordered pairs is the signs, right? When you're in quadrant 1, everything is positive, right? You go to the right and up, all of them are positive. In quadrant 2, you go to the left and then up. So all of my cosines are negative. That's the only difference, okay? And now we're at negative 1, 0, right? From the origin, we went to the left 1, up or down 0, okay? Now let's do quadrant 3 degrees. Remember, we're adding 30, 15, 15, 30. So if I add 30 to 180, I get 210. Add 15 is 225, 240. Do you guys remember this one from Friday? 270. But it's mathematical. Plus 30, plus 15, plus 15, plus 30. Guys, notice something that maybe you notice. All of my quadrant 1 angles are less than 100. In quadrant 2, they all begin with a 1. In quadrant 3, they all begin with a 2. And guess what's going to happen in quadrant 4? They all start with 3. We'll get to that in a second. Back to ordered pairs, okay? In this quadrant, look, if you are hugging, here's my x-axis, guys. If you look at my fingers, if you're above the x-axis or below it, I call that hugging it, you're the same ordered pair. So this is going to be square root of 3 over 2, 1/2. We'll come back to the sign. The middle is always square root of 2 over 2, square root of 2 over 2, and then flip. 1/2, square root of 3 over 2. But this is also a y-axis hugger, right? So on either side of the y-axis is the same ordered pairs. Well, we're in quadrant 3. Cosine and sine are negative, right? To the left is negative, down is negative. So all of these are negative. And I'm doing it obnoxiously like that to kind of encourage you to as well, because when I have to grade yours, I don't want to have to guess if there's a negative there or not. All right. And then we're down here at 0, negative 1. And let's finish. Add 30. Remember I said it was going to start with a 3. Add 15. Add 15. All the way around is 360 degrees. If you are hugging the y-axis, 1/2 comes first. If you're in the middle, square root of 2 over 2, square root over 2 over 2. And if you're hugging the x-axis, the square root of 3 comes first. The signs in quadrant 4, we go to the right is positive, down is negative. So my signs are negative, S-I-Ns. That is the unit circle. So again, look at my fingers. The huggers of the x-axis, look at my 4 fingers. They are all the same ordered pair. The ones that hug the y-axis, where my fingers are, they are the same ordered pairs. All the middles are same ordered pairs. Degrees, less than 100, in the hundreds, in the 200s, in the 300s. All of my denominators of 4 are the only ones that the degrees end in a 5. 45, 135, 225, 315, all the other degrees are ending in a 0. There's so many little things that we're going to be talking about, okay? Another trick for the signs, okay? There's a little mnemonic I don't know if that's called a mnemonic. Maybe you guys will tell me. Here's the coordinate plane. You want to draw this. We're going to use this for the rest of the semester. All students take calculus. Quadrant 1, 2, 3, 4 in that order. All students take calculus. Okay, that is is the word mnemonic? Let me tell you, I don't know. Whatever. All students take calculus. What that stands for is who is positive. Who is positive? So in quadrant 1, all are positive. Sine is positive, cosine is positive, and we'll learn tomorrow about tangent. Tangent's positive. Everybody's positive in quadrant 1. In quadrant 2, only sine is positive. So by default, the other two, this is sine, this is tangent, this is cosine. Okay, so by default, cosine and tangent are negative. Here, only tangent is positive. Sine and cosine are negative, and so on. Cosine is positive, so the other two are negative. And that goes right along with this picture I drew you. Like, you might not need that trick so much. You should be able to kind of come up with who's positive and negative just because it's a coordinate plane. But this is a quick way of doing it that is very helpful. It's going to be really helpful in future lessons. Okay? So, here's the thing. What you are going to do is we're going to do the first 3 homework problems together. And you can just copy my key and be done in 5 minutes. You can ignore my key and just have this out and copy from here because everything in your homework is sitting right here on this piece of paper and on my key. But what I'm going to encourage you guys to do is what I'm going to model for you with the homework. So let's first get to that page, 25. And let's write this down, and then let's start it together. Okay? I want to do it together. First 3. If you cheat yourself right now, you're just cheating yourself. Okay? If you start trying to learn the patterns, if you start trying to learn the patterns now, you're going to be better off every single day that you try and try and try to learn this, the better off you're going to be. Okay? And here's what I mean. Finish writing that. And you don't have to find tangent. We're just finding sine and cosine. You ready? All right. So number 1 is let's find sine and cosine of this angle. So first thing you're going to do, oh, I forgot to tell you I'm so sorry. I have to tell you one more thing. That's so important. I'm so sorry. You'll still finish your homework. Guys, where do these radians come from anyway? So understand this. This is just please, please, please listen. From 0 to pi, we already talked about half of the unit circle is pi. The full one is 2 pi. Notice that in our top half of the circle, our radians are all what we call proper fractions, meaning the numerator is less than the denominator. That's 1/6 of pi, 1/4 of pi, 1/3 of pi. Okay? Then it's 2/3 pi, all the way till we get to 5 pi over 6 is almost 1, right? Because 6 over 6 would be 1. So we're getting bigger. But here's where the confusion comes in. This is such a common mistake, is students confuse these two angles right off the bat, okay? And here's why you can't do that, and I'm going to explain how you won't anymore if you listen. But notice that the ones that hug the x-axis all have a denominator of 6. That's really important. These are all my denominators of 6. These are all my denominators of 3. Where does that come from? Well, guys, if I offered you pizza, okay? I ordered 2 pizzas for this class, whatever, and one of them is cut into thirds. You get to have one of these, or you get to have, pretend it's equal, one of these. Which one is bigger? 1/3. Clearly, 1/3 of a pizza is bigger than 1/6 of the pizza. What students do erroneously is they look at the denominator like, oh, 3 is smaller than 6, so it must be smaller, 1/3. It's not. 1/3 is greater than 1/6. So when you look at the unit circle, that's why the denominator of 6 comes first. That's the smallest section of pi. 1/6 of pi, 1/4 of a pi, 1/3 of the pi. It goes right in order. So 6 denominator is smaller than 4 or 3. Okay, so that's what's really important. And that just repeats over and over. All of my denominators of 6 start with the square root of 3. All of my denominators of 3 start with 1/2. All of my denominators of 4 are my middles, and they have that identical twin cosine and sine. Okay? So, right away, this is what I want you guys to start doing. You see a denominator of 3, you picture it in your brain, you see it up at the top. Denominators of 3 are hugging the y-axis. They always start with a 1/2. All of my denominators of 3. Picture it. Don't memorize it. Picture it. Denominators of 3, and if you know quadrant 1, it matches all the other quadrants. Denominator of 3 is up closest to that, and that's the 1/2. Okay? Then you have to come up with what quadrant, and I'm going to teach you some tricks on that tomorrow. You could use your key for that today. One thing you should notice, though, is that it's an improper fraction. All of the radians down here are greater than 1, because this is 1 pi. This is 1 and 1/6, 1 and 1/4, 1 and 1/3, and so on. So this is in quadrant 4. It's hugging the y-axis, so that's where 5 pi over 3 would be. So what you're going to tell me is what sine and cosine are. You can write it in any order. Just remember, sine is your y value, cosine is your x value. Okay? All of my denominators of 6 start with the square root of 3. How are you going to remember that? Think of the pizza. If you're a denominator of 6, you're the smallest one in your quadrant. So you're hugging the x-axis. They all start with the square root of 3. So get your ordered pair, then the signs are what comes next. By what quadrant it's in? This is definitely in quadrant 3 or 4 because it's an improper fraction. For now, you might need to look at the quadrant. This is quadrant 3. This is a quadrant 3. This is quadrant 4. And so if it's a denominator of 6, it hugs the x-axis. So it's going to be closest to the x-axis. So sine is 1/2, cosine is square root of 3 over 2. You can see probably how we get confused between our denominators of 6 and our 3 because it's the same two fractions. It's the order you have to memorize. I see a denominator of 4, I go, hallelujah, that's the easy one. All of my denominators of 4 have those two as the cosine and sine. And then this is actually in quadrant 3 as well. Oops, sorry, I forgot to do my signs. These are both negative in quadrant 3, right? We're going to the left and down to get to this point. So that's negative, negative. So they're both negative. Sorry about that. Same thing here. This is in quadrant 3. All my denominators of 4 go right in the middle. And I will, like I said, show you tomorrow the easy way of knowing what, it's super easy, what quadrant everybody's in. But I don't want to give you too much today. And they're both going to be negative, right? Quadrant 3, they're both negative, right? So you're going to continue on. You don't have to draw the angles anymore. You are just going to find sine and cosine. So test yourself, guys. Don't just copy. See if you can find it in your brain first, then look at the key or your answers. I originally had 9, 11, and 13 assigned. I crossed them out though, so ignore the pink circle on those. On my desk right there. No tangent today. We'll do tangent tomorrow. We're going to play. We're going to have a great old time tomorrow. Mrs. Sunday is recruiting for her AP statistics class. If anyone thinks they're interested, there's a flyer on it. She put all the types of degrees that require you to have statistics in college. You might be able to get it done in high school. So that's on the back if anybody wants one. Also, I've printed tons and tons of practice unit circles for you. feel free to help yourself to these. I put 2 to a page. This is so you can start practicing. But you probably won't be ready to start practicing until tomorrow, but I'll put them up there if you want them. I have tons of them uploaded onto Canvas as well. But those are for you if you want to grab some to start practicing for yourself.